Hello, everyone, and welcome to today's Explainer. Right now, we're diving into what is literally a make or break element of greenhouse farming, and that is greenhouse soil disinfestation. Look, whether you're growing high-value ornamentals, leafy greens, or massive vine crops, what you do before a single seed even touches the dirt, well, that pretty much dictates your entire season. So we're going to break down exactly how you can prepare your soil to absolutely maximize health and yield. Seriously, imagine boosting your greenhouse's productivity simply by changing the way you prepare your soil. We are going to unlock the secrets to healthier plants and much higher yields right now. Okay, here's our roadmap for today. We'll cover 1. Why disinfect greenhouse soil, 2. Chemical methods and limitations, 3. Heat treatment, 4. Anaerobic soil disinfestation, 5. Practical steps for beginners, and 6. The future of soil health. Let's jump right in. Section 1. Why disinfect greenhouse soil? To start, we really need to understand the stakes here. Greenhouses are amazing because they provide the perfect warm, humid conditions for your plants to thrive. But the harsh reality is that those exact same conditions are an absolute paradise for microscopic enemies hiding right under the surface. We're talking about a massive, hidden army of threats. For instance, if you look at the pathogens that routinely attack greenhouse crops like cucumber and zucchini, it's pretty wild. You've got soil-borne fungi like fusarium and pythium, alongside some really harmful nematodes and bacteria. If left unchecked, these can cause up to a 75% yield loss in susceptible crops. 75%. If you don't control these populations early on, your crop's viability is, well, it's in serious danger. And to put the sheer scale of this problem into perspective, the global cost of managing plant diseases is a staggering $220 billion every single year. So managing the health of your soil isn't just about saving a few wilted plants, it's a massive economic necessity. Section 2. Chemical methods and limitations. Now, for decades, the agricultural industry's go-to weapon against these microscopic threats has been chemical fumigation. Let's look at how these work and the inevitable trade-offs involved. It's kind of a double-edged sword. On one hand, chemical soil disinfestation offers broad-spectrum action and immediate pest suppression. Basically, fumigants wipe out a huge range of threats all at once. That makes pest management super straightforward, especially in resource-intensive greenhouses. But these methods come with some really heavy long-term drawbacks. Historically, older fumigants like methyl bromide were huge contributors to ozone depletion. And while modern alternatives are definitely better for the atmosphere, they still present real toxicity risks. Plus, and this is crucial, they drastically reduce the diversity of beneficial microbes in your soil. Take basamid, for example. It's a really popular granular fumigant made of 98% dazimate. The way it works is when it touches moist soil, it actually decomposes into highly toxic gases like MITC to kill the pests. Because we're dealing with dangerous gas here, you have to use specialized, highly impermeable plastic covers, like Sotrafa's DS+, just to seal the ground so the gas doesn't escape and poison the greenhouse air. It's incredibly effective, sure, but repeated use basically strips your soil of its organic matter and beneficial microbial groups over time. It leaves the soil kind of lifeless. Section 3. Heat treatment, specifically steam and solarization. Let's pivot away from the chemicals and look at physical soil treatments. These rely purely on heat to get the job done. The two main physical methods are steam and solarization, and they couldn't be more different. Steam is lightning fast, blasting the soil at temperatures between 70 and 90 degrees Celsius. It leaves zero chemical residues, which is a dream for organic farming. The downside, extremely high energy and equipment costs. Solarization, on the other hand, is highly sustainable and cheap. It uses the sun's heat to reach up to 60 degrees Celsius. The catch with this one is that it requires a consistently hot climate, and it takes 3 to 6 weeks. That means your greenhouse is literally just sitting empty, not making you any money during that entire window. Now, if you go the steam route, how deep you're actually treating the soil depends entirely on your gear. Subsurface injection can heat the soil down to about 19 centimeters, which is fantastic for your deeper-rooted crops. Surface pans, though, only reach about 9 to 13 centimeters down. But, that shallow treatment is often perfectly fine for short-cycle, intensive crops like leafy greens, because you harvest them long before any pathogens deeper down have a chance to swim back up to the surface. And again, absolutely no harmful residues left behind. If you're lucky enough to be in a sunny region and opt for solarization, here's how it works. You lay clear polyethylene or special VIF plastics tight over moist soil. By trapping that solar energy for 3 to 6 weeks, you essentially slow cook the pathogens to death. But here's a really cool bonus. This cooking process actually accelerates the decomposition of organic matter in the soil, which naturally increases the availability of essential nutrients like nitrogen and phosphorus for whatever crop you plant next. Section 4. Anaerobic soil disinfestation, or ASD. Okay, this is where things get really exciting. This is a rapidly growing biological alternative that perfectly bridges the gap between killing pests and maintaining long-term soil health. ASD works through completely natural fermentation process, and you execute it in 3 pretty straightforward steps. First, you apply a rich carbon source. We're talking something like 40 tons per hectare of fresh organic material, or you could use a specialized mustard meal fertilizer. Second, you cover the soil tightly with an airtight VIF plastic tarp. And finally, you heavily saturate the soil underneath with water and let it sit for 3 to 8 weeks, depending on how warm it is. So what does this actually look like in the field? Usually, a tractor churns and incorporates all that fresh organic material deep down into the dirt. Then the soil gets rolled completely flat, heavily irrigated until it's holding maximum water and sealed off with a virtually impermeable film. Underneath that plastic, the soil microbes go to work. They consume literally all the available oxygen while breaking down that organic matter. This completely suffocates the pests. Better yet, the microbes release natural, volatile fatty acids during this process that are absolutely lethal to pathogens, but completely safe for the broader environment. And the results? They are incredible. Research out of the University of California shows that fields treated with ASD yielded up to 120% relative to untreated control groups. 120%, because you see, it doesn't just kill the bad guys, it actually promotes the growth of beneficial bacteria and fungi, restoring a highly productive, healthy balance to the entire soil ecosystem. Section 5. Practical steps for beginners. Look, whether you use steam, solarization, or ASD, literally none of it matters if your baseline greenhouse hygiene is terrible. So let's run through some really practical, everyday steps to prevent disease from taking hold in the first place. An ounce of prevention is worth a pound of cure, right? First off, ditch the wooden benches. Wood harbors algae, rot, and insects. Swap them out for easy-to-clean wire benches and laminate potting tables. Next, install foot baths with fresh disinfectants at every single entrance. At the end of your season, be sure to flush your irrigation lines with products like sulfuric acid or hydrogen peroxide to destroy any buildup of slime and biofilm. And finally, a really simple but absolutely critical rule: keep all your hose nozzles off the floor. Leaving a nozzle in a puddle on the ground is basically a fast track to sucking soil pathogens up into your entire watering system. Section 6. The future of soil health. The agricultural industry isn't standing still. It is constantly innovating to solve these complex soil and pathogen challenges. One major trend is, well, entirely bypassing the soil altogether using hydroponics and soilless cultivation. Theoretically, this starts you off completely pathogen-free. Though it's worth noting, you still have to manage waterborne diseases like Phytophthora if your plants get stressed. Beyond that, researchers are doing mind-blowing work integrating artificial intelligence and hyperspectral imaging to detect invisible pathogen outbreaks in real time, long before they can spread. There's even new development in photoselective films that allow very specific light wavelengths to penetrate the soil for highly targeted solarization, all while preventing water loss. The future is looking pretty high-tech. Before we wrap up, I want to quickly tackle a super common myth. Does steaming or fumigating kill absolutely all soil life forever? The short answer is no. But it absolutely decimates your beneficial microbes in the short term. And that actually leaves your soil super vulnerable to opportunistic bad bacteria if you aren't really careful about how you manage the recovery. That is exactly why integrating biological methods like ASD, or at least adding disease-suppressing compost right after you do a physical heat treatment, is so vital. It rebuilds that complex, resilient microbial network that gives you long-lasting disease suppression. So the biggest takeaway here is simple. Healthy, vibrant soil means healthy, vibrant yields. Take the first step in improving your soil health today. Actually, I would love to hear what methods you are currently using in your own greenhouses, so please drop your experiences down in the comments for us. And finally, a quick note. This explainer is for educational purposes only. Please always consult a professional agricultural advisor or a certified soil scientist for specific advice regarding your unique greenhouse conditions. But as we wrap this up, I want you to ask yourself one question next time you walk out to your crops. Is the soil in your greenhouse working for you, or is it working against you? Thanks so much for joining me, and happy growing.